Now we will talk about enantiomerism and diastereomerism, right? What are enantiomers and what are diastereomers? We have been doing this since our previous lectures, right? But now we'll just specifically look at what are enantiomers and what are diastereomers, right? We have, in the previous video lecture, we were talking about L-lactic acid and D-lactic acid. This is your L-lactic acid, this is your D-lactic acid, right? These in lactic acid, right, in D or L-lactic acid, we have a chiral carbon. Now, chiral carbon is that which is connected to 4 different atoms or groups, right, like this. And it is non-superimposable on its mirror image. If you look at this, D-lactic acid is non-superimposable on its mirror image, right? And one form will rotate the plane of polarized light towards right, and the other form will rotate the plane of polarized light towards left, right? And they, very important, they cannot be superimposed on one another, right? Object is not superimposable on its mirror image, that is, it cannot completely overlap on its mirror image, right? So these compounds, these isomers which are mirror images of each other and cannot be superimposed, right, are enantiomers, right? These are enantiomers. So we define it as when a molecule possesses chirality. When we say that molecule possesses chirality, that means carbon atom is connected to 4 different atoms or groups, right? And such a carbon atom is your asymmetric. This is your asymmetric carbon atom or chiral carbon, right? We also call it as a stereocenter, right? So when a molecule possesses chirality, it can exist in 2 non-superimposable stereoisomeric forms. These are 2 non-superimposable stereoisomeric forms which are mirror images of each other, right? These forms are called enantiomers and the phenomenon is known as enantiomerism, right? I repeat, when a molecule possesses chirality, right, that is, it is asymmetric, and one more condition, this is dissymmetric, it does not possess any elements of symmetry, right? So carbon atom is asymmetric and this molecule as a whole is dissymmetric, right? So when it possesses chirality, it can exist in 2 non-superimposable forms which are mirror images of each other. These 2 are non-superimposable mirror forms, and these 2 are also mirror images of each other. Now these 2 forms, D and L-lactic acid, are called as enantiomers, right? And the phenomenon is known as enantiomerism, right? I hope this is clear now. Now some properties of enantiomers are, we know that since these are isomers, so they possess same molecular formula, and they also have same chemical structures, right? They possess almost similar physical and chemical properties. However, there are some differences, right? Now one difference we know that one enantiomer will rotate the plane of polarized light towards left and the other will rotate the plane of polarized light towards right, right? One is your dextrorotatory, right, which rotates the light towards right, and the other is levorotatory, which rotates the light towards left, right? And enantiomers may possess different rates of reaction with other optically active compounds, right? Rate of reaction for this may be different from rate of reaction of this. One may react faster, the other isomer may react slower, right? So this is a difference. And they may differ physiologically. When we say physiologically, like histidine is a compound that exists in these kind of enantiomeric forms, D-histidine and L-histidine, right? And D-histidine is sweet, whereas L-histidine is tasteless, right? dihistidine is sweet, right, whereas L-histidine is tasteless. Right, so they may differ physiologically. Similarly, L-nicotine is more poisonous than D-nicotine. L-nicotine is more poisonous than D-nicotine. Right. Now let's look at what are diastereomers and what is diastereomerism. Diastereomers are similar, like these two optical isomers are mirror images of each other, right? Now, the optical isomers of a compound which are not mirror images of each other are your diastereomers, right? And the phenomenon is diastereomerism. So, which optical isomers are these, right? Which optical isomers are these that are not mirror images of one another? If you remember, we talked about tartaric acid. Tartaric acid exists in three forms: D form, L form, and your mesoform. Right? Mesoform is optically inactive, this is optically active, this is optically active. Now, these two we have discussed in the previous lecture that these two are mirror images of each other. Right? These are non-superimposable mirror images of each other. Right, and here carbon, it contains asymmetric carbon atoms, right, two chiral or asymmetric carbon atoms, right, and this is a dissymmetric molecule, this is not asymmetric. If you divide this, try to divide this from this half, right, it would not be divided into two exactly same parts, right. So these two that are non-superimposable mirror images of one another are your optical isomers. These are enantiomers, right? These are enantiomers which are non-superimposable mirror images of one another. Now, if I try to compare this and this, right, this and this, if I write it over here, OH, you have H, OH, COOH. Right. If I put a mirror, right, if I try to compare it with this form, this is what? These are optical isomers. These three are optical isomers, right? But these two are enantiomers. Remember that, understand this thing, that these are isomers, optical isomers. Why these are optical isomers? Why these are isomers? Because their behavior towards plane polarized light is different. This will rotate towards right, towards left, this will not rotate, right. If you remember the definition of optical activity, right. So all these three possesses same molecular formula, but their behavior towards plane polarized light is different, right. So all these are isomers, we call these as optical isomers, but these two are enantiomers. Why? Because they are mirror images of one another, right. Similarly, if you compare this and this, right, like this, COOH. Now these two, this is your D-tartaric acid and this is your mesotartaric acid, right. This is your mesotartaric acid, this is your D-tartaric acid. Now these two are optical isomers, right, but are not mirror images of one another, right. So such optical isomers that are not mirror images of one another, as in tartaric acid, are diastereomers, right. Very important. Just understand the difference between enantiomers and diastereomers. These are enantiomers, right, which are non-superimposable mirror images. These, in tartaric acid, we have three optical isomers, right, but only two are enantiomers, right. These two are enantiomers because they are mirror images of one another. Now, if we compare this D or L form with your mesoform, Both these are not mirror images of meso tartaric acid, this one. So the pair of the optical isomers that are not mirror images of one another are your diastereomers, and this phenomenon is your diastereomerism, right? So this, your D form and your meso form are diastereomers. Similarly, your L tartaric acid and mesotartaric acid are your diastereomers, right? So remember, diastereomers are opposite of enantiomers. Enantiomers are mirror images of one another, whereas diastereomers are not mirror images of one another, right? I hope this is clear. Thanks.